Hi everyone, welcome to another video. Now, we've looked at quadratic expressions before and looking at completing the square and applying this to factorizing. Now, like we did in last year's content when we looked at quadratic expressions and equations, now we need to move on to actually looking at working with equations, thinking how we can first take some kind of quadratic expression on this left hand side, factorize it, and find solutions for x that give us 0 on the other side. Now, completing the square is a really useful way to work with these type of questions where it's not immediately obvious what our factorization would be. So if we look at a regular question like this, normally we would look at our PSF method and we'd say, okay, we want two numbers that multiply to give me 2 and add to give me -4. Well, here this is a little tricky because we have, okay, with this 2, its factors can be, to give me +2, it can be -2 or -1, but -2 and -1 add to give me -3, not -4. So that's clearly incorrect. And if we tried, for example, +2, +1, these add to give me 3. So once again, clearly not correct. We don't get something that adds to give me -4. So we need another approach. So what we're going to do is we're going to look at factorizing this by what we talked about in the previous couple of videos, completing the square. And this is going to build us up to some very unique ways of solving these types of equations. Okay, now what we're going to do is we are going to complete the square. So if you remember from the previous couple of videos, we need to take this coefficient, and in order to make a perfect square here, something that will be factorized, we need to do something with this middle coefficient of x, which will, and add it at the end, which will give me a perfect square factorization. So what we're going to do is we're going to have x squared, revision from last lesson, we are going to add to that, we're going to halve my b coefficient here. Remember, this is my b, and I have my A, and that's my C. So that's what I mean when I say B. We're going to take B, divide it by 2, and then square that. And remember, we can't just add something out of the blue. We need to subtract it as well to counterbalance that, to give us something that is still this expression here. Because these terms are going to sum to give me 0 or subtract to give me 0. So nothing's really changed here from my first one to my next one down here. Okay, and then I have +2 running out of space here equals to 0. Okay, so what do I get here? Well, I get x squared minus 4x, and then -4 divided by 2 gives me -2, all squared gives me +4, and I'm subtracting 4 and adding 2, and that's equaling to give me 0. Okay, now once again we have this in a form of our perfect square, just like in the last video, and then I have the constants here as well, my just regular numbers. Okay, perfect. So now my perfect square, I can factorize this. If you'd like, pause the video and use PSF to revise, but we covered this a lot in the last video, so I'm just going to skip to actually factorizing that. Oops. Because -2 and -2 multiply to give me 4, and they add to give me -4. So I'm going to have two factors that are the same. So I get x minus 2 times x minus 2. I can write that as x minus 2 all squared. And then here, minus 4 plus 2 gives me minus 2. And that gives me 0 here. Okay, so once I get here, there's two ways we can go about doing this. So, method 1. What we're going to do here is we're just going to solve it normally. Once we have this, x minus 2 squared minus 2 equals 0, we can just solve this equation to get x on its own. So we want to strip away all these things attached to x. So starting from the one furthest away, we're adding 2 on both sides. That gives me x minus 2 all squared equals to positive 2. Now I'm going to take the square root of both sides to get rid of this square here. So just leave me with x minus 2. So on my left, I'm going to get x minus 2. And on my right hand side, remember when I take the square root of a number, I can have both a positive and a negative case. And I have root 2. Because root 2 times root 2, so positive root 2 times positive root 2 is going to give me 2. But also, negative root 2 times negative root 2, we have a double negative. So those negatives are going to cancel out, once again giving me a positive answer. And now that we're here, I just have x minus 2 equals to plus or minus root 2. And I just want to add 2 to both sides. To leave me with x on its own here. And then I have 2 plus or minus root 2. Now it's important to note something here. This plus or minus means I have two different solutions. Here I have two solutions for x, because remember when we solve quadratic equations, usually, not always, we will get two solutions. So my solutions here are 2 plus root 2 and 2 minus root 2. These are my two solutions here. Okay, now let's backtrack and have a go at another method. And this revises some of the key ideas we talked about in last year's quadratic equations section, as well as last video when we talked about further factorizing something like this. So what I'm going to do, I'm going to write this out again and look at how we can do another method here. Now, some of you may prefer this method, some of you may prefer method 1. It's up to you to choose how you want to go about doing something like this. But this way is more aligned to what we looked at with quadratic equations when we looked at regular factorization and solving. Now, in the last video, we said that my x minus 2 squared, I can leave this like this, but my 2 can be written as root 2 all squared. Now, remembering that a square root and a power of 2 are going to cancel out just to give me 2. So, this is a valid way of expressing 2. So we haven't changed anything on my left-hand side. That's the most important idea here. Now here we have a difference of 2 squares. 2 squares. Okay. Now, when we have a difference of 2 squares, that means we have this term and this term in my brackets. So not the squared part. But we're going to have x minus 2 here, and we're doing some operation with root 2, and we have x minus 2, and then another operation with root 2 equals to 0. And when we have a difference of 2 squares, the signs in here and here, one is going to be positive, one is going to be negative, so that we can cancel out those middle two terms. So all I end up with is this squared minus this squared, which is what we have up here. So I'm going to put plus root 2 minus root 2 equals to 0. Okay, now, if we remember from what we looked at last year, we have a multiplication happening here between these two expressions. And that has to equal 0 on the right-hand side. Now here we want to use an idea we defined last year as the null factor law. And just to refresh everyone's memory, that just means that if I have two things multiplying, let's say an expression A and expression B to equal 0, one of these, A or B, must be 0. We can't get a product of 0 unless one of the factors are themselves 0. So what we're going to do is we are taking two cases, one in which this expression equals to 0 and this expression equals to 0. So therefore, I have x minus 2 plus root 2 equals to 0, or I'm going to leave some space here, x minus 2 minus root 2 equals to 0. So I have a case where my expression highlighted in pink equals 0 and my expression highlighted in green equals to 0. And we want to find the value of x that makes each of those equal to 0. Okay, so here I'm just going to solve my equation. Now I have negative root 2. I have positive root 2, so I can subtract that from both sides. And I have a minus 2, so I can add that to both sides. So I'm doing this quickly because hopefully by now we're okay with solving these types of equations. I'm going to first subtract root 2 from both sides and then add 2 to both sides in order to get rid of this and give me x on its own. So I get x here equals to, now I've added 2 here, and I have subtracted negative root 2. So I have subtracted root 2, which gives me negative root 2 on the right hand side. And now here, I'm going to add root 2. Now I'm going to add 2. This is going to clear both of these terms. Sorry, I should have done that up here. That gives me x on its own equals to 2 plus root 2. Or in other words, see, we have the same things, but we have a plus, a minus, or plus root 2. So we can write this as that, or x equals 2 plus or minus root 2, which is exactly what we got for my method 1 up here. Okay, now I know it seems like a long process, but we are just working through this a little slower, just so we can get the ideas happening. But I'm going to do one more example, which we're going to work through together, once again doing it really slowly, and I'm just going to pick one of the two methods here to do, just so we can save a little bit of time. Now we have another quadratic equation here with which the left hand side cannot be solved via just PSF, because there is no way that two factors of 1, so 1 and 1, or -1 and -1, are going to add to give me -3. So we have to use completing the square. Now, what are we going to do here? Well, we are going to, remember, take our b coefficient, halve it, And then that's going to be used to complete our square. So I have x squared minus 3x plus minus 3 on 2 all squared. And remember, I need to, since I've just pulled this out of nowhere, I need to subtract that 2 in order to make my second line of my equation the same as this first one. So I want to leave everything preserved still. I can't just add this thing here and then make something brand new. I need to subtract this once again, but I'm just doing a little bit of mathematical manipulation here. Now, what do I get here? I get x squared minus 3x plus, and negative 3 on 2 all squared gives me 9 over 4. And I'm subtracting from that 9 over 4 plus 1 equals 0. And every single time you can hopefully see I'm ending up with a perfect square section, something that factorizes really nicely into a perfect square, and my constants here. Okay, so my perfect square, feel free to pause and do this with PSF, but we've done actually, I think, this exact example in the previous video. So I'm just going to go through and just factorize this now. So that gives me x minus 3 over 2 all squared. And here I have negative 9 on 4 plus 1. That gives me negative 5 on 4. And that equals to 0. Okay. Now, I'm just going to do this using method 2 so we can practice our null factor law once again, because we talked about that at length in the previous series. So I don't want that time to be wasted. We're going to just apply everything we know because it's quite a useful idea. Okay, so we have x minus 3 over 2 all squared, and minus, I can write 5 over 4 as root 5 over 4 all squared equals 0. Once again, because the squaring and the square rooting, those are going to cancel out, leaving me just 5 on 4 here. Okay, so remember now we have a difference of 2 squares. Difference of 2 squares. And how we factorize these, if you remember from a bunch of series we've looked at this idea, we have just this term and my term here inside my 2 brackets, and the signs between those, one's going to be positive, one's going to be negative, in order for those middle terms to cancel out, giving me, when we re-expand it, this expression up here on the left. So I have x minus 3 on 2 plus root 5 on 4. And we have, let's give ourselves some more room, x minus 3 on 2 minus root 5 on 4. And that equals to 0 on the right hand side. Okay, now because these are multiplying, there is a multiplication implied here with these 2 binomial products. We want a case in which both of these equals 0. So I can have the possibility of x minus 3 on 2 plus root 5 on 4 equaling to 0 by the null factor law. I'll actually write that here. So null factor law. Okay, so let's go ahead and solve that. So I'm going to subtract root 5 on 4 from here, from both sides, which will clear this, and I'm going to add 3 on 2 to both sides to clear this. leaving me with x on its own on the left-hand side, equaling to 3 over 2 minus root 5 on 4. So that is this guy over here. That is the case, a value for x that makes this left-hand bracket equal to 0. Now we want to find a value for x that makes this right-hand bracket equal to 0. So I have x minus 3 over 2 minus root 5 over 4 equaling to 0. And then I just want to solve this equation to give me x on its own on the left-hand side. I'm going to do that by adding root 5 on 4, 3 on 2. And that gives me x equaling to, sorry, let's just make this really clear. That's isolating the x on its own here because the other two are going to be equal to 0. And that gives me 3 on 2 plus root 5 on 4. Or in other words, I can write this as x equals to 3 on 2 plus or minus root 5 on 4. Because I have 3 on 2 in both, but I have a minus and a plus. So I can write this as a short way. X equals 3 on 2 plus or minus root 5 on 4. Now, this is how completing the square works in a practical setting for solving our quadratic equations. And what we've essentially done is we have still gone back and done the null factor law things we were looking at in the previous series. The only thing here is where the hardest bit is tidying up our initial quadratic equation by completing the square and giving us this same repeating idea that we looked at in the last video of having a perfect square, part of my left-hand side expression of my equation, and the constants as well. So then we can break these up into two sections and then go about solving using our null factor law once again. But that brings us to the end of the video. Thank you so much for watching, and I'll see you in the next one.